We had some problems where you had products of sines or cosines in an integrand, and you found the antiderivative by doing u substitutions. One example of that was, let's say you had the integral of cosine of cubed x sine x dx. Well, remember that the integral of sine by itself is negative cosine, or the integral of cosine by itself would just be sine. So keeping that in mind now, I have a product with sines and cosines. Now, what I want to do first is see what a u substitution work. I know if I choose u to be either a sine or a cosine, I'm going to get the other one. So if I choose u for sine, u to be sine, then the cosine would be the du. And if I choose u equal cosine, the du is going to have a negative sign in it. So I need to choose first to see if a u substitution will work. And then if that doesn't work, then I'm going to show you this alternative process. This is to handle products of sines and cosines, or just powers of sines and cosines. So first I would try u equal cosine of x here. And the reason I'm choosing this one is because I have this lone sine of x over here that could be my du if the u were a cosine. So choosing u equal to cosine of x, the du does come out to be just a negative sine of x dx. And so I see that a u substitution is going to work. I'm going to put a minus here so that I'll have the negative sine x dx, and I'm going to put another minus 1 out in front to keep my problem the same. So this ends up being a negative 1. Then the integral, I'm changing the cosine of x to u, so this will be u to the third, and then there's my du. So a simple your power rule application here would be minus u to the fourth over 4 plus c, and then I can just go right back to my cosine. So this will be minus cosine of x to the fourth over 4 plus the c. So first look for a u substitution if you have that product of sines and cosines. And the hint is, do we have one sine or one cosine over by itself in that product? And that's when the u substitution is going to work nicely. Okay, so now these are our basic integrals. We had the integral of sine of x is negative cosine of x plus c. Secant squared is just tangent. The integral of cosecant squared is negative cotangent. The integral of cosine is going to be just sine. The integral of secant tangent will be secant, and the integral of cosecant cotangent will be minus cosecant. So those are your basic integrals. Now the formulas that are going to come in really handy on doing some of these integrals are our power reducing formulas. That's the main one you're going to use. And then this double angle identity sometimes comes up. Now, if you remember your double angle formula for sine, sine of 2x was 2 times sine x cosine x. So if you see a product of sine and cosine in an integrand, you could do it by just using this identity and changing that product over to 1/2 sine of 2x, and then you can just integrate the sine of 2x using the u substitution real easily. So the times you're going to use these power reducing formulas are when you end up with an even power of sine or cosine in the integrand. So if you had the integral of sine squared of x back in calculus 1, what we did was we just changed it to this 1/2 1 minus cosine of 2x, because you can integrate a cosine of 2x easily just using this main formula up here in a simple u substitution, u equal 2x. So even powers of sine and cosine, when that's all that's there, use these power reducing formulas. Okay, so now, 2 things to look for. Look for odd powers of one of the two, sine or cosine, or all even powers. If you have only even powers of both of them, you're going to use the power reducing formulas. If there's one of them, sine or cosine, that has an odd power, you're going to break one off, and that's going to be your du, and you're going to do a u substitution. So in this first problem, I have an odd power of a cosine. I'm going to rewrite this as cosine to the 4th x times a single cosine. That makes it easier for me to get ready for my u substitution. Now, this single sine or cosine with the dx is going to be your du, or part of your du. It may not be exactly the du. Worry about numbers and signs, S-I-G-N, later, but this will be at least a portion of your du. So if your du had a cosine in it, what would the u need to be? So the u, if the du is going to have a cosine in it, it's going to have a sine. So I'm going to let u be the sine of x, and then figure out what your du is going to be. Your du will be just a cosine of x dx, and now you're ready to make your u substitution. So this becomes the integral of the cosine to the fourth, but I can't change that to u's. U is only sine. I don't even have any u's in my problem. Remember, what we need to do is we need to change everything over to u's. Well, to change that cosine to the fourth to u's, it needs to be in terms of sines. So that I can do also. Remember your Pythagorean identity. I know that sine squared plus cosine squared, both of x, equal to 1. So that means cosine squared of x is 1 minus sine squared of x. Well, that means then that cosine to the fourth of x, I'm just going to square both sides here. You're squaring the entire side, is equal to that. So the first thing I'm going to do then is I'm going to change this cosine to the fourth x to 1 minus sine squared of x squared. And then I still have that cosine x there, dx. And now I've got it all set up. Here's my du. And this sine here, the single sine, will just be my u. So I now have the problem 1 minus u squared du. And now we've just got it down to a simple power rule, but we do need to expand that out because you can't do a u substitution here because you have the variable squared inside the parentheses and there's not a single variable outside the parentheses. But we can expand this thing out using the FOIL, which will be 1 minus 2 times u squared plus u to the fourth. I'm just expanding it out. It's just the distributive property or FOIL. 1 minus u squared times 1 minus u squared. And now applying the power rule is going to give me u minus 2u cubed over 3 plus u to the fifth over 5 plus my c. Going back to my original variable, I now have sine of x minus 2 times sine cubed of x over 3 plus sine to the fifth x over 5 plus c. Okay, so now let's look at this next one. I don't have an odd power of sine or cosine to be able to break off for my du. So all I can do here is the power reducing formulas. So you have to keep in mind that sine of x squared is equal to 1/2 1 minus cosine of 2x. So it'll double the angle going to the right side. So that means if I have a sine to the fourth, I'm going to square both sides. I'm going to have sine squared squared is sine to the fourth, and I have a product over here that I'm squaring. So the 1/2 squared is 1/4, and then I'll have 1 minus cosine of 2x squared. So substituting that into my problem, the sine to the fourth becomes the integral of 1/4, which I'm going to pull that out in front, and then I have 1 minus cosine of 2x squared. Well, I could handle it if it was the integral of cosine of 2x, but I need to expand that because I've got that whole parentheses there squared. So I'm going to expand it out. That's 1/4 the integral of 1 minus 2 cosine of 2x, just using the distributive property, cosine squared of 2x. And now I can handle the integral of 1. I can handle this one. That'd just be a u substitution for that 2x. And I can handle this one, but it's going to require another application of the power reducing formula. It's a cosine to an even power only. So this one, let me break this up into multiple integrals. This is going to be 1/4 x. I've integrated that 1. And then plus 1/4. Actually, go ahead and pull that minus out there. I'm going to have minus 2/4, the 2 in the integral and the 1/4 outside. And now the integral of cosine of 2x. And then plus 1/4 times the integral of cosine squared of 2x. So I just broke it into multiple integrals, so I can do each term separately. Okay, so now cosine of 2x, this one actually requires a u substitution. The u would be the 2x, no dx there. So I'll have 1/4 x minus 1/2. The integral of cosine of 2x will be 1/2 sine of 2x. That's just after an application of u substitution, u equal 2x. And then plus 1/4. And for the cosine squared, I'm going to apply the power reducing formula again. I know cosine squared of 2x by the power reducing formula will be 1/2 1 plus cosine of 4x. It always doubles the angle when you use the power reducing formula. So I'm going to change that out. So this is going to be the integral. I'm going to put the 1/2 in front, and then I'm just going to be integrating 1 plus cosine of 4x. So now one more step here. I've got my x over 2 minus 1/4 sine of 2x. I have a 1/8, and when I integrate the 1, it's just going to be a single x. Integrate the cosine of 4x, it's going to be a 1/4 sine of 4x. Again, just a u substitution, letting u be the 4x for that part of it. And then you're going to have a plus c. So if I want to combine some things, I've got a 1/8 x here and a 1/2 x here. So that's going to be a 5/8 x minus my 1/4 sine of 2x. And then plus my 1 over 32, just distributing this 1/8 times the 1/4 sine of 4x. Okay, so even powers of sine or cosine in a product or by themselves requires that power reducing formula. Okay, sine to the 4th cosine squared. Okay, my rule of thumb is if there's an odd power of one of them, I'm going to break one of them off. And that will be my du, so then the u needs to be the other one. And then change everything else to that other one. This one, though, doesn't have an odd power, so I'm going to need the power reducing formula. So for sine to the 4th, first off, I'm going to rewrite this as the integral. I'm going to think of it as sine squared of x squared, and then I've got the cosine squared. So now, using my power reducing formula, that sine squared there is just going to be 1/2 1 minus cosine of 2x, and then this whole thing is going to be squared because of the square right here. And then I have times the cosine squared is another 1/2 1 plus cosine of 2x. Okay, so now I'm going to pull all those 1/2s out. I've got the first 1/2 is in the brackets, so that's going to be a 1/4 when I square it. So the 1/4 there pulled out, and the other 1/2 is going to make it 1/8, the integral, and I've got that 1 minus cosine of 2x squared, and then I've got a 1 plus cosine of 2x. Okay, so I'm going to need to expand that out, because there's no product rule, but you have to expand it out and have it just individual terms added together. So I'm going to have 1/8. I have the integral of 1 minus 2 cosine of 2x plus cosine squared of 2x times 1 plus cosine of 2x. Okay, and we need to use the distributive property and actually expand that all out. So this is going to be 1/8. The integral 1, I'm going to do 1 times each of the terms in the second parenthesis, so 1 plus cosine of 2x, and now, I guess I did the 1 times this and the 1 times this one, and now I'm going to do the second term times each one of them, and then I'll do the third term times each one of them. So I have minus 2 cosine 2x times 1, and then I have minus 2 cosine squared of 2x, and then I have plus a cosine squared of 2x, and then I'm going to end up with the cosine cubed of 2x. Long problem. Okay. I'm going to combine the first two that are like terms. Actually, the second and third terms. The fourth and fifth terms are like terms. I can combine those. So let's clean that up a little bit. I have 1/8 the integral of 1 minus a cosine of 2x minus a cosine squared of 2x, and then plus a cosine cubed of 2x. And I'm going to look at this as separate integrals. I can handle the 1/8 times the integral of 1, and then I'm going to have minus a 1/8, and then an integral of cosine of 2x, and then I'm going to have minus the 1/8, the integral of cosine squared of 2x, and then I'm going to have a plus 1/8, the integral of cosine cubed of 2x. I'm going to write this one as cosine squared of 2x times a single cosine of 2x. Okay, but I distributed my 1/8 all the way through. Okay, the first one is simple. The integral of 1 is just x, so I've got 1/8 x. The next one here isn't too hard. It's just going to be a little u substitution. You'll be equal to 2x, so I'm going to have minus a 1/16 sine of 2x. The next one is an even power of cosine. Yep, you're going to have to do it. 1/8. It's going to be the integral. Power reducing formula again for this is going to be equal to cosine squared of 2x is 1/2 1 plus cosine of 4x. So I'm going to bring the 1/2 out in front, and I'm just going to end up with the 1 plus cosine of 4x in the integram. And then the last one here, I'm actually going to do it because it was an odd power of cosine. I'm going to do it as a u substitution. Okay, so the u substitution here is going to be u equal. Now remember, if you broke one off, that's going to be the du. So my du is going to need a cosine in it. So that means my u is going to have a sine in it. So my u here is going to be sine of 2x, but I don't even have any sine of 2x's in that problem, but I'm going to make some sine of 2x's. I'm going to change this cosine squared to 1 minus sine squared of 2x. And then that cosine of 2x will be my du. Okay, so du, now du will actually be cosine of 2x times the 2, because you've got to remember the chain rule, take the derivative of that 2x. So 2 cosine of 2x dx. Okay? So when we're making this substitution, I need to have a 2 with this part, so I'm going to stick a 2 there, and I'm going to have to put a 1/2 out in front here. So I'll do that in this next step. Okay, so now let's see if we can get this problem finished up. We have x over 8 minus sine of 2x over 16 minus 1/16 times the antiderivative of the 1 here will be x, and then our antiderivative of the cosine of 4x will be 1/4 sine of 4x. Okay, then I've got plus the 1/16, and I've got the integral 1 minus sine squared of 2x, so that's 1 minus u squared, and then that 2 cosine 2x dx is my du. Almost there. So I'm going to go ahead and combine this 1/16 x, negative 1/16 x, with the x over 8, which is 2/16. So I'm going to end up with an x over 16 minus sine of 2x over 16. And then I'm going to have minus 1 over 64 sine of 4x. And now I have plus 1/16, and I'm going to take the antiderivative of this, which will be u minus u cubed over 3. I'm not going to worry about my plus c to the very end. Okay, so now I've got x over 16 minus sine of 2x over 16 minus sine of 4x over 64 plus. Now this 1/16 times the u, that's going to be sine of 2x. Remember, your u was sine of 2x over 16 minus 1/16 times 1/3, so that's going to be the u cubed over 48. So that's going to be sine of 2x cubed over 48. And we're all finished except for the plus c. Actually, I see some terms that could cancel. This and this one would cancel. They have the same, sine of 2x. So our final answer then, x over 16 minus sine 4x over 64 minus sine cubed of 2x over 48 plus c. We've got one more here. Let's hope it's a lot shorter. I want to go through one more real quick where you look at odd powers. This one has a sine cubed cosine to the minus 2. I'm not going to worry about that cosine to the minus 2. I see an odd power, though, of a sine cubed, which I'm going to pull one of those odd ones off to be my du. So I'm going to end up with the integral of sine cubed, but I'm going to write it as sine squared of x. I'm going to go ahead and put this cosine to minus 2x, and then I'm going to put that one single sine of x out there to the side. So now this is going to be my du. So what did u need to be? If du is sine, the u needed to be something with cosine. Okay, so now choose your u based on that. But now what would the du actually be? The du would actually be a negative sine of x. Okay, so to get that negative sine of x, I need to put a negative in here and another negative out. Whoops, that one just jumped around. Another negative out here in the front. Okay, so now my u is cosine, so that means that any sines out here need to be switched over to cosine. And it should be an even power, though, if you pulled one off, if it started off being odd. So this is going to be a negative, the integral of 1 minus cosine squared of x. And here's our cosine of minus 2x, and here's our minus sine of x dx. And now we're ready to make our u substitution. We've got our negative 1 minus u squared times a u to the negative 2, and then there's our du. Now, to integrate this, we're going to need to multiply it out. Again, there's no product rule for integrals, so you want to write it as sums of powers. So this is a negative, the integral of u to the minus 2 minus u squared times u to the minus 2. You add the exponent, so that's u to the 0. I'll write that down, which is just 1. So now I've got the integral of u to the minus 2 minus 1 du, which will just end up being negative u to the minus 1, add 1 to the power, negative 2 plus 1 is negative 1, and divide by the negative 1. And then the integral of the 1 is just another u, and then we'll have a plus c. So now let's go back. Let's clean all this up. I've got a negative and negative 1 at the bottom, so that's going to be positive. U to the minus 1 is just the same thing as 1 over u. 1 over u minus u plus c. And so the 1 over u is 1 over cosine of x minus the cosine of x and plus the c. So luckily that one was much easier. So look for those, an odd power of sine or cosine when you have products of sines and cosines. Now all this is summarized on this next slide. It just says your strategy. Now m and n are the powers on the sine and the cosine. If m is odd and n is just any real number, it doesn't matter if it's a fraction, a negative, whatever, as long as one of the two of them is odd. If m is odd, that's the power of sine, you split off the sine. Then you rewrite all the rest of it as powers of, all the even powers of sine that are left in terms of cosine. So if you break off that single sine over at the side, you better have a sine. It's going to end up being m minus 1 the exponent, but this will be an even power, which then you can turn into cosines. So your du will be the sine, have a sine in it, but your u will actually be a cosine. Okay, if n is odd and m is real, this just says if the cosine one is the one odd, you break one of those off. So split that off, that's going to be your du. And then change all the others that are there so that they're the u, which will be the sine. Okay, so break off the odd one, whatever it is, and whatever that is part of the du, but your u's the opposite of that one. If both of them are even, or if they're both non-negative integers. or if they're both even, non-negative integers. If you had a sign to the -2, you're not going to be doing this with, you can't use the power reducing formula with negative powers. But if both of them are even, you're going to use half-angle formulas to change them. And what that does is it's reducing the power by 1, and you might have to apply it multiple times. Okay.